Okay, hello everybody. Finally, I got everything set up. Sorry for the time you've been waiting for the live streaming. So, I'm very happy to announce that the day after tomorrow, it's going to be our final exam for QBUS5001. So today, I'm holding this live streaming to help you guys do some quick revisions on some common areas of difficulties that you probably struggled with, as well as solving some of your specific questions, okay? So basically today we're going to do two things. First of all, we'll be using some some questions, practice questions or past exam questions to illustrate your understanding of some knowledge, okay? Past exam questions. And secondly, what we're going to be doing is it's the question and answer time, which means you can ask any questions in the live chat and then I'll answer it. Try my best to answer it, okay? So, do you want to do the past exam question first or question and answer first? So if you want a past exam question first, please input 1 and question and answer input 2, okay? I'll give you 10 seconds, make it a quick roll. Oh my God, great. Oh, come on, yeah, thanks. Okay, most of you is choosing 1. So let's start from the first one, past exam questions, okay? All right, actually, for your final exam, there are several key areas that you need to pay attention to. One is hypothesis testing, which hasn't been tested in your mid-semester exam, but in your final exam, it will be tested, right? And the new things after the new things from hypothesis testing is that is ANOVA, right? And non-parametric test, as well as linear regressions, okay? So what we're going to be doing is to look at some past exam questions in 2012, because I think those questions are very good for you to do some quick revision. Okay, I'm distracted again by your chats. Like 2 equal to 1 plus 1, so all for 1. What is your logic? That's interesting. Okay, I'll try to adjust the angle of this device, trying to cover as many things as possible. Okay, I think this is much better. All right, now let's start from a ANOVA question, okay? Because I believe most of you has prepared a lot of things in hypothesis testing, right? Especially in your mid-semester exam. So I don't think there should be any problem on the hypothesis testing. Now, let's start from ANOVA, which is a new area that we learned after the mid-semester exam. Now, before we move on to a specific question, let's think about the problem, ANOVA. What do you think the ANOVA is testing? Or what are the null hypothesis and alternative hypothesis for ANOVA test? Well, great. So basically, we're going to test multiple population means are equal or not. So the null hypothesis is mu1 equal mu2 equal mu3 equal mu k, right? So k means the number of groups that we have for the whole test. And for H1 is at least 1 mu I not equal to mu j. At least one pair of mu I doesn't equal to mu j. So ij equal to 1 to k, and I does not equal to j in any way. And the test statistic is the F statistic, which is calculated by MSR over MSE, which follows the F distribution with the degree of freedom K or K minus 1. You tell me. K or K minus 1. This is different from our overall significance test in our regression analysis, right? So here should be K minus 1 exactly. And the second one should be N minus K instead of N minus K minus 1. Oh my god, what happened to my it's a bit strange. Sorry, I'll adjust the angle of this device a little bit because it seems like it's very naughty. It keeps changing its angle, so I can't make it focus on the same area. Oh, no way. Okay, sorry about that. Let's go back and see our ANOVA test. Therefore, we got F statistic as MSR divided by MSE, and this can be, and the decision rule is if your observed F greater than the critical value, which is, oh, shit. Well, let's pause for 1 minute, and I'll adjust this bad boy for a little while. Oh, okay. It's too bad. Okay, I think it's much better. Alright, sorry about that. So if F observed value greater than F critical value, then we reject the null hypothesis, right? And again, if P value less than alpha, then we also reject the null hypothesis. Okay. Alright, so now let's move on to a question together from probably 2012 semester 1. Let's see this question together. So it worth 15 marks about ANOVA. A business analyst of a large Australian cafe chain wanted to compare the weekly sales of the cafes in Sydney, Melbourne, Brisbane, and Adelaide. In each city, he randomly selected 10 cafes, and their weekly sales amounts were recorded as below. Okay, so those are the data from our sampling. Okay. Oh, someone saying it's not very clear. Is it? Is it clear now? Okay. Well, probably you can see the recording if you can. Okay. Then, to analyze the data, he used the following one-way ANOVA model. So this is just our one-way ANOVA model, and obtain the following computer outputs using both parametric and non-parametric method. So for parametric test, it should be ANOVA test, and for non-para, it should be the Kruskal-Wallis test, right? Okay. Now let's look at the questions. So all of those are the Excel outputs. So let's see the questions. Oh, where are the questions? Eh? It's so strange. Oh, sorry. Where did I put the questions? Oh, sorry, it's here. Okay. So all of those are the informations, and let's see. First of all, is this a balanced design or unbalanced design? So this is just a question. I mean, a concept question. Oh, some of you saying you can't see anything. So please try to refresh this page and see if you can see it. Okay? Yeah, just refresh it. Now, first, what is the balanced design or unbalanced design? So a balanced design is that for each treatment, the sample size should be equal, right? And the unbalanced design is that for each treatment, the sample size is not equal. So do you think this is a balanced design or an unbalanced design? Great, it's a balanced design because we can see for each group or each treatment, the sample size are 10, right? So the sample size is 10 for each group. So it's a balanced design. Awesome. Now, second one. If the parametric method is used, what assumptions needed to be made about a random error term epsilon ij? So do you remember in our one-way ANOVA model, what is the assumptions on the error term? Do you remember? Basically 3 things, right? So first of all, the error term should be what kind of distribution? Normal distribution, exactly. So the error term should be normally distributed. And what about the mean and variance? So the variance of the error term should be constant. Great. And thirdly, what is the what else? What about the relationship between different error terms? They need to be independent to each other, right? So independent. Okay, so those are the 3 requirements or the assumptions for using a parametric test, right? Because if any of those assumptions, especially the normal assumption, is not met, then we need to use the non-parametric method, right? Okay, so thirdly, complete the ANOVA table. So we can see here, we've got a ANOVA table here, is that right? So what we need to do is to complete this ANOVA table. Oh my God, I badly need a calculator. What should I do? Okay, that's okay. So first of all, let's fill in the degrees of freedoms. Okay, for degree of freedoms, what is the degree of freedom for between groups k or k minus 1? It should be k minus 1. So we have 4 groups together, so the degree of freedom should be 3. And for within groups, what else? Within groups, it should be 36, right? N minus k, which is 40 minus 4. Okay, Kelly Wang is asking, could we just write the error term follow normal distribution IID? Actually, you can, but you'd better write it down and then, write it down and then explain what does that mean. So break it down into 3 parts, okay? Normal, constant variance, and independent, all right? Okay, hopefully this answers your question. Now, for between groups, can anyone calculate this SSR for me? Is that okay? So it should be SST minus SSE, right? So just get this SSR number. Can you do that? I think at the same time, I should open up an Excel. Open Excel as a calculator. Oh, great. Thank you, Daniel. So Daniel says it's 1119.61. 1119.61. Now, what about the mean squares? So this is MSR and MSE. So can anyone help me calculate this MSR and MSE? It should be the SSR divided by their degree freedoms, right? And this SSE divided by the degree freedom. So can anyone help me calculate those 2 numbers as well as the F number, okay? Okay, so Felisa has calculated MSR as 373.20. Thank you very much, 373.20. And for MSE is 57.74. Brilliant. And what about F? So F is just MSR divided by MSE. So what do you think? 6.46. Thank you, Farhan Hossein. 6.46. So now let's compare this F value with this F critical value. Do you think we should reject or not reject the null hypothesis? Definitely, F is greater than F critical, so we reject the null hypothesis at 5% level of significance or any level of significance. But the question 3 only asks us to complete this ANOVA table, okay? All right. Question number 4. State the null and alternative hypothesis being tested in the ANOVA table and draw your conclusion at the 5% level of significance. Okay, so we need to state the null and alternative hypothesis first. This is what we done just now, right? So the null hypothesis should be H0. H0 is mu1 equal mu2 equal mu3 equal mu4. Is that right? So all the sample means, all the population means should be equal to each other. And for the null alternative hypothesis, it's at least what? One pair of mu I not equal to mu j. Okay, so those are the null hypothesis and the alternative hypothesis. Okay, now it's asking you draw your conclusion at the 5% level of significance. We know the observed value of F statistic is calculated as 6.46, which is greater than F 0.05. What are the degree freedom? 3 and 36, which is equal to 2.87. So this critical value has already been provided on here, okay, 2.87. So this one greater than this one, therefore H0 is rejected, and we have enough confidence to say what? We have enough confidence to say that what? At least one pair of mu I not equal to mu j, or not all the population means are equal, right? Now let's go back and see the real meaning of the means. So it's the mean sales amount, right? So we have enough confidence to say that not all population average sales for the 4 different cities are equal, something like that. Cities, okay, cities are equal. Okay, so you just see the real scenario and then draw your conclusion. Okay, all right. Jun Xiu Ling is asking, Dear Tony, we need to build a more detailed answer than what you're writing right now. Am I right? What I suggest is that you need to answer what you are asked. Okay. So in this question, actually my answer is very enough to get a full mark. So it just state the null and alternate hypothesis. So I just state the null hypothesis, and then draw your conclusion at 5 level significance. So this is the decision rule, and here is the conclusion. So I've included everything of what the question is asking. Okay, so probably what you mean by building a more detailed answer is that if the question is asking perform a one-way ANOVA test to test the equality of the population means, and then you need to write the full steps of a hypothesis testing. Okay? Yeah, I know. Yeah. All right. Now, let's see question 5. if the null hypothesis in 4 is rejected, which pairs of cities have different weekly sales? Okay, if you have done your major assignment independently, you must know if we reject the null hypothesis in ANOVA test, we need to figure out which one pair of mu I not equal to mu j by what? By multiple comparison, right? So here we can see we've got the multiple comparison results. One is LSD, the other is omega. So basically, we will be looking at this omega, right? So LSD is not the one that we'll be looking at. So let's see which of the two cities are not equal. 6.32 less than 9.11, right? So this is equal. 11.86, 9.11. So 11.86, Sydney and Brisbane. 13.5, 9.11, Adelaide. And all of those are less than 9.11. Therefore, when we look at the W or the omega, we conclude that the Sydney and Brisbane and Sydney Adelaide has significantly different average sales. Okay. Now let's see. If null hypothesis is rejected, which pairs of cities have different weekly sales? So which pairs? So from the multiple comparison output, we know that the sales between Sydney and Brisbane and Sydney and Adelaide are different, okay? So this is fairly easy, right? Okay. All right. Now, let's move on to the next one. If the non-parametric Kruskal-Wallis test is used, what conclusion will you draw at 5% level of significance? So in terms of the Kruskal-Wallis test, all you need to know actually is just to read the result. Or for all non-parametric tests, just be able to read the results, okay? So Kruskal-Wallis test, we have a p-value here, so we just compare it with the significance level and then draw our conclusion, okay? So for this Kruskal-Wallis test, we know the p-value is 0.0024. Therefore, we know if, what we will draw. So since the p-value of Kruskal-Wallis test is 0.0024, which is less than 0.05. Therefore, the null hypothesis will also be rejected, right? Will also be rejected, and we can conclude that what? Not all population means are equal, or not all population locations are equal, right? The location of the sales of the 4 cities okay, not all of the 4 locations of the sales of the 4 cities are equal, okay? All right, so many ofs, but hopefully you understand what I mean here, right? Not all of the location of the sales of the 4 cities are equal. Location means central location, right? Because when we because when we are doing the non-parametric test, we're not talking about the mean, right? So many of you has made a mistake in your major assignment by saying when you perform a like Wilcoxon ransom test, you write down mu1 equal mu2. This is definitely wrong, okay? Because we never talk about, this is the parameter, right? But it's a non-parametric test. So the null hypothesis and alternative hypothesis should be the locations are equal or locations are not equal, okay? Instead of mu1 equal mu2 or mu1 not equal to mu2, okay? So that's all about the non-parametric test. Okay, so 7. If you were the business analyst, would you use the non-parametric method for the data analysis? And explain briefly. So here, what kind of knowledge shall we apply in answering this question? It's all about assumptions, right? Okay. So, if it's about assumption, let's just do a quick review of when to use non-parametric and when to use parametric, right? It's basically about the normal assumption, the normal population assumption. So if the population follows a normal distribution, then we'd better use parametric test, right? And if it is not normally distributed, we'd better follow the result of the non-parametric test. Is that right? Okay. However, someone is saying, okay, so since non-parametric test does require much less assumptions on the data, shall we always use non-parametric test? Not really, okay? So I was asking, since non-parametric test requires less assumption, because this assumption here is very strict, the population must be normally distributed in order to use the parametric test. But for non-para, we don't require any normal assumption, right? Okay, so can we always use non-parametric no matter it is normal or not normal? The answer is no, okay? Because one drawback of non-parametric test is that for all non-parametric tests, they actually we lose some information of the data, right? So basically, we can see that the information of the data for parametric tests, we will use the numerical value of the data. For example, 12, 6, 5, 2, something like that. So when we calculate like average, we can get the exact central location, right? However, in non-parametric tests, we are using the rank of the data. This will definitely lose a lot of information in the data, okay? Therefore, as long as the population follows a normal distribution, then we will prefer to use the parametric results, okay? So even if only if it is not normal, then we have no other choice but to use the non-parametric test, okay? All right. Now, let's see the questions from our students. Okay, well, let's finish this question first before we see the questions from the students. So if you were the business analyst, would you use a non-para or non-parametric or parametric? So this is basically looking at the normal assumption, right? Now let's see. The output here has a chi-square test of normality. So we know for the chi-square test of normality, the null hypothesis is normal or not normal. Null hypothesis is normal, right? And therefore, the alternative is not normal. Therefore, when we look at the p-value here, they all greater than 0.05, which means we do not reject null hypothesis, right? So we do not reject null hypothesis. This means all the data are from a normal population, right? So the normal assumption is valid in this scenario, in this situation. So do you think we should prefer parametric results or non-parametric? Okay, so it should be parametric, right? So if you were the business analyst, would you use the non-parametric method for data analysis? Explain briefly. Here, I won't, right? I won't, because the populations follows a normal distribution, right? From the chi-squared test of normality, right? Therefore, if we use non-parametric test, we will lose what? Information. Because we are using what of the data? We are using the rank of the data instead of the numerical value of the data. Okay? So this is how we analyze, okay? We can answer this question. All right, let's look at the question. So Felisa Zen is asking, if we get a p-value, can we just use that in our answer, or do we also need to use statistic value or critical value to get full marks? So this is based on the requirements of the question, okay? So if the question is asking you use p-value, then use p-value. If it is asking you critical value, then critical value. So if it's not stated clearly, you can use any of them, okay? So Farhan Hossein is asking, is it that we get 1 mark for pointing out the p-value and the other 1 mark for drawing the decision regarding the null hypothesis? I think so. Yeah, I think so. Yeah. Jia Hao Lu, do we need to calculate the H by formula? I'm not quite sure, but in history, the calculation has not been examined, but anything can happen in this semester, right? So you better know how to calculate it, the H, okay? But I know it's too complex. I mean, it's impossible for them to give you the rank and then you calculate the H, right? It's too complex. So it's probably the possibility of testing it is less than 1%, okay? All right, Kelly Wang, if the data is not normally distributed and is greater than 30, could we use CLT and then use the parametric test? Actually, yes. Actually, yes. But you know what? If we want to use the t-test or this f-test, we always assume a normal population, okay? So it's not working in that way, okay? Hi, Tony. Could you please explain when shall we use the t plus or t minus? It is very confusing when thinking which t value to use. Thank you. So as I mentioned, it's all about the p-value and the decision. I don't think that calculation is really, involved in your final exam, because I've asked Ming about that page of the lecture slides, and he also got confused. So I don't think it can be tested. But if it is, I will somehow adjust, as what I did in your mid-semester exam, okay? I will adjust the marking criteria for those questions that can never be answered by the student, okay? So if that is the question, that they do have this kind of question, I will give everyone full mark, okay? Can you show us how to calculate beta type 2 error? I think it's part of your major assignment, but I'm currently not very sure about calculating beta. So for beta, let me think. It's when something happens. All right. Well, can I go back to you later on someday or in anywhere? Because I don't have the beta calculation, like formula on hand, and I also don't think it can be tested. But if it is, well, it's just similar to your semester. No, I mean the major assignment, right? Okay, so I'll go back to you later on. Clary Huang will be asked to do non-parametric manually. So, well, from my perspective, the possibility of testing manual calculation of non-para is less than 1% because it's too complex. But it's still possible to ask you what is the rank of a specific data. Okay, like we have 3, 2, 1, 4, 8. So what is the rank of these two? Okay, so you need to know what is the rank of a specific value. So that's from experience. Okay, but as I mentioned, anything can happen, right? Okay, Quinton Wang. Why the degree films SSE as a one-way ANOVA and MELA are different? Well, that's a good question. Well, if you do want to have an explanation on it, it's really hard to explain here because you need to understand what is a degree of freedom. But I can give you an intuitive understanding. So for example, if we are dealing with a ANOVA set of data, the K is actually the number of groups that we have in total, right? So the SSR has a degree of freedom of K minus 1, right? However, in a multiple linear regression model or multiple linear regression analysis, the K is actually the number of independent variables, which means the K is excluded the Y, right? Exclude one column. Therefore, it's still the total number of groups minus 1. But since K here means the number of independent variable, so it's already the total number of group minus 1. So that's why the degree of freedom of SSR is K. But in ANOVA, K is the total number of groups. So it will be K minus 1. It's again, lost 1 degree of freedom here. So they basically the same thing, but just a different definition on the K. Okay? So are we gonna have questions about 2 or 3-way ANOVA tests? I don't think they are. You've learned anything about 2-way or 3-way ANOVA, so you don't need to worry about them. So Rennie Chen is asking if the data is not normally distributed when n is greater than 30, do we prefer parametric or non-parametric? Well, it's still non-parametric, I guess, because especially for Kruskal-Wallis test, we do have a requirement on the error term, which should be normally distributed. So I think non-para is still preferred. Quinton Wang is saying, yes, it is possible, like they asked us to calculate accumulated distribution manually in mid-semester exam. Well, what Ming has told me is that he has checked the final exam paper in very details and to make sure every question is doable in your final exam, unlike the mid-semester. So you don't need to worry that much. Like final should be more friendly than your mid-semester exam, okay? Elsie is saying because Y can also be viewed as a treatment. Yes, it is. Thank you very much. That's a good answer. All right, so do you have any other questions? If not, we're going to move on to the next topic, which is the linear regression, okay? Any questions so far? Any questions? Okay, if you don't have any more questions, I know we left a calculation of beta, the power of the test, and explained. So I will have a research later on Wikipedia or somewhere and trying to calculate beta. Okay. All right. that's all about this ANOVA question. Hopefully you all got very happy with all of them. Now let's do a quick revision of the linear regression and then look at some specific questions, okay? So first of all, hopefully you all remember, well, Bella Neuron is asking, do we need to calculate p-value for the ANOVA? No, you don't need to do that because we can only calculate that using Excel, okay? Like this is the same as a t-test. So for t-test, it's impossible for us to calculate the p-value without an Excel, okay? So for t-test and f-test, you only need to know the critical value approach, okay? Where could we find this paper? Canvas? Well, what about I update this paper and then share it to you because I haven't uploaded it yet. Okay, so after this live streaming, I will upload it. And this link will be right under the description of the video, okay? It will be under the description of the video down here, okay? So you just click show more here and then you will see the question. I mean, after the live streaming. So for the audiences now, you cannot see it definitely, all right? Okay, now, it's time for us to do a quick recap on the regression. So if you are the students who comes from my tutorial, you probably know we have how many steps for the linear regression. How many? 5 exactly. Thank you very much. So the first step is called testing on what? Testing on the correlation, right? Okay, so we need to look at the existence of any correlation between independent variable and the dependent variable, right? So correlation. So for correlation test, we have 2 sets of tests. One is called Pearson and the other is called what? Spearman. So for Pearson test, it's parametric, and for Spearman test, it's non-parametric. And this works in the same way of the normal assumption, right? So if the normal assumption is met, then we use parametric. And if it is not normally distributed, we use non-parametric test, which is Spearman correlation test, right? Okay, step 2. The step 2 is basically, basically what is it? The model, yeah. How to build a model as well as an estimation, right? So in this question, you need to know the difference between a model and the estimated model, right? So when we talk about a statistical model or linear regression model, it is constructed by y equal beta 0 plus beta 1 x1 plus beta 2 x2 plus blah, 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 plus beta k xk plus an error term, which is epsilon, right? Okay, so this is what we call a model, and it's like a population regression model, right? And we know this model can be broken down into 2 parts. The first part is this deterministic part, which is the straight line. And the second part is the error term, which is stochastic or random, okay? So this is the model. Part 1, part 2. So the part 1 is fixed, it's a straight line. And part 2 is random, which is an error term. And we know this error term has the same assumption of our ANOVA model, right? Normally distributed with conditional mean of 0 and the same conditional variance, IID, right? Okay, so this is about the model. Now, for estimated model, it's gonna have 2 parts again. One part is the estimated equation, which is the estimation of the fixed straight line. Estimated equation. So this equation is given by y hat equal to beta 0 hat plus beta 1 hat x1 plus beta 2 hat x2 plus beta k hat xk. Okay, so this is what we call the estimated equation. So the purpose of estimated equation is for prediction. Okay, it's for prediction. Again, in terms of the error term, as what we mentioned in our tutorial, the error term actually also have their estimations, which is what? Residual, right? So we know that the residual EI hat or EI is calculated from YI hat minus, YI, which is observed YI minus YI hat, right? So this is what we call the residual. And we know that residual is part of what? The error term, right? So residual is a part of the error term. Residual is like a sample of the error term. So this is like a population error term, and those are the observations of the error term, okay? So if we draw it on a diagram, we probably know if this is a set of sample that we've sampled from a population, and after we calculate a regression equation, so this is the regression equation, and the rest of the difference goes to the residual, right? So this is what a residual is depicting, okay? So this difference of the actual value and the predicted value is the residual, okay? So that's all about the model and estimated model. So in the exam question, if you are asked, write down the model that you applied, then you need to write down the model. And if you are asked, what is the estimated equation, then you need to write down the estimated equation, okay? All right. Now, in terms of residual, I've mentioned one thing, which is the estimation of this guy, this bad boy, which is the variance of the error term. So what is the estimate of the variance of the error term? Do you remember? It is MSE. Brilliant. And what is the estimate of the standard deviation? It's square root of MSE. Okay, so this is very important. If you know it, you can definitely get easy mark, but if you forget it, then you just forget it, okay? Yeah, excellent. So Clary Huang is talking about MSE. So LC is say the power of a test needs assumption of the true mean. There's a graph of relationship between beta and true mean in textbook, but it's based the hypothesis testing assuming a false mean. Okay, whatever it is. That's good. Thank you for your contribution, Elsie. Okay. So that's all about the estimated equation and residual. Okay, you need to know the difference between them. What's next? Step 3. In our step 3, after we make an estimated equation, we can actually do what we call prediction. So in terms of prediction, the point prediction is very easy, right? Sorry, let me drink a cup of water. Look at this water, right? It's good. Okay, step 3, prediction. In terms of prediction, after you got an estimated equation, it's very easy to do a prediction. You just plug in all the x values, right? And then calculate the y value, right? So that's pretty easy. However, what is hard is that to calculate a confidence interval and a prediction interval. Since the calculation is too heavy, I guess you'll probably only be able to explain the difference between confidence interval and prediction interval, okay? So confidence interval is actually estimating the average, right? The average y for all items that has the same x, right? But for prediction interval is for a specific person or specific item or entity, specific person who has a specific set of x, and then we do a prediction interval. Okay, so that should be the difference between the confidence interval and prediction interval. You probably have done that in your major assignment as well, so I don't want to spend too much time on that. Now, the most important thing is on step 4. Basically, step 4 is about testing the goodness of the model, right? How good the model is. So we've got 3 packages. Do you remember that? The first package is called what? R's, right? We have a lot of R's. So for the R's, we have what? For all of the R's, we have firstly R square. So you need to be able to explain what R square mean, right? So R square is the percentage of total variation in Y. Okay, so the variation in Y is very important, especially the variation, okay? Percentage of total variation in Y that is explained by the model, all the independent variables, all the explanatory variables, okay? That is explained by the model, all the explanatory variables or whatever. But the key things is the variation in Y, okay? So the first thing we need to know is the R square. R square is calculated by SSR over SST, right? So this is just too easy for us, I guess. And for adjusted R square, it's calculated by 1 minus MSE over MST. And we know adjusted R square will usually act as a criteria for selecting the best model, because adjusted R square has overcome an issue in R square, because R square will always increase when K increase. However, for adjusted R square, when K increase, it can increase or decrease. It depends on if the independent variable you've added is important or not important, okay? So adjusted R square is better than R square in multiple linear regression analysis. And the last thing is multiple R. So for multiple R, 2 things you need to know. Multiple R is calculated by the square root of R square. So it's just the R, right? And it depicts the correlation between Y, your observations, and Y hat, okay? So square root of R square is depicting the correlation between Y and Y hat. So if it is asking you, what is the correlation between Y and Y hat? You need to know it's multiple R, okay? Quentin Wang is asking, are these 5 steps including your tutorial material on Canvas? Yes, they are. Okay, multiple R. And another thing is that especially in simple linear regression, right? Simple linear regression, the correlation between Y and X will be plus or minus R squared. It depends on whether Y and X has a positive relationship or a negative correlation, okay? So that's all about the multiple R, okay? So that's all about the R's, goodness of the model. And second part, other than R's, we do have a overall significance test, right? Overall significance test. So for overall significance test, we know it's a F test, right? So overall significance test is actually testing if all the betas of the independent variables are 0 or not, right? So it's from beta 1, remember it's from beta 1, okay? No beta 0 here, okay? Beta 1, beta 2, beta 3 to beta k, all equal to 0. And an alternative hypothesis is at least one beta I is not equal to 0. Okay, so that's all about overall significance test. And for this overall significance test, the test statistic is again calculated by MSR over MSE, which also follows the F distribution with a degree freedom k minus 1 and n minus k minus 1. All right. It's k. K and n minus k minus 1. This is different from the ANOVA test. Okay. And again, the decision rule can be F greater than F critical or p-value less than alpha, and then we reject the null hypothesis. Okay, so this is very easy. Now you probably practice it a lot in your major assignment, I guess. Yes or no? I'm not quite sure, but you need to know the overall significance test, right? That's all about details of the overall significance test. Now the third thing. The third thing is the individual significance test, right? So for the individual significance test, it's a t-test, right? And the null hypothesis and alternative hypothesis is beta I what? Equals 0. A specific beta equals 0. And a specific beta not equal to 0. Okay, so this is the individual significance test. So for the individual significance test, the test statistic t is calculated by beta I hat. So one thing you need to keep in mind is that never write beta hat equals 0 in your hypothesis, okay? Because the hat are the sample statistics you estimated, right? But for the hypothesis, we are testing on parameters, okay? So the parameter is the population coefficient, okay? The population coefficient is what in our model, which are beta 0, 1, 2, instead of in our estimation, 1 hat, 2 hat, 3 hat, okay? So the hypothesis should just beta instead of beta hat, okay? Now, the t-test statistic is given by beta I hat divided by the standard error of the beta I hat. So the standard error can be found on the second column of the Excel output, right? So the first column is coefficient, second column is the standard error. So the standard error is just over there, okay? It's just standard error. All right, so that's all about the individual significance test, okay? Now, fourthly, again, what we have for the goodness of the model is sometimes we want to remove some independent variables, right? For example, if I got a full model like y equal to, for example, beta 0 plus beta 1x1 plus beta 2x2 plus beta k xk plus epsilon. However, I want to, for example, remove in total p independent variables here. Okay, I want to remove p independent variable from this model and see if this restriction is valid or not. Okay, so then the reduced model becomes beta 0 plus beta 1x1 plus beta 2x2 plus blah 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 plus actually to beta k minus p xk minus p. So the last p independent variables are actually removed from the data, right? From our model, all right? So this is the full model and reduced model. So I want to see if those reduced model has a significant, the independent variables that we removed from the model has a significant impact or significant explanatory power on the variation in y. okay? So what we're gonna do is also perform a F-test, okay? This is called a partial F-test, okay? So this partial F-test has a null hypothesis, which is the betas of the removed independent variables equal 0, which means from beta p plus 1, beta p plus 2 until beta k are equal to 0, okay? And for an alternative hypothesis is at least one of the beta I is not equal to 0, and I equal to p plus 1, p plus 2, to k. Okay, so the last p, not p, this should be. Oh, this is k. Oh, sorry, k minus p plus 1, k minus p plus 2. My bad. So k minus p. Okay, you know what I mean, right? It's just all those betas are equal to 0, which means the betas that you remove from the model is 0 or not, okay? And now, what you're gonna do is construct the F statistic to see if the explanatory power of all those models are equal or not. Are significant or not, okay? So what you're gonna do is to use the SSR of the full model minus the SSR of the reduced model and divided by the number of reduction, okay, which is P. And then divided by SSE of the full model divided by n minus k minus 1. So this is the F statistic, and this one is the only test that you need to perform manually or calculate it manually in your exam, okay? So you need to know how to calculate this. We will later on use the past exam question to illustrate how we apply this partial F test, which will probably help you better understanding of the partial F test, okay? So, and this F follows the F distribution with the degree freedom P and n minus k minus 1. Again, the null hypothesis will be rejected if F larger than critical value or P value less than alpha, same thing, okay? All right, so that's the partial F test. So how can we understand the partial F test? So basically, let's see. If this box is SST, okay? So what is this SST constructed of? It must be broken down into what? SSE and SSR, right? Now, my question is, let me find another color to try to illustrate this. Okay, good. I have so many colors. So now, if we remove some independent variables here, okay? If we remove some independent variables, what will happen to SSE and SSR? So we know SST will never change if we add on or remove any independent variables. The only changing things are the SSE and SSR, right? So if we remove some independent variables, what will happen to SSR? It will decrease, right? And SSE will correspondingly increase, okay? And result in a smaller R square, is that right? Okay, so this shadow is actually the total explanatory power of those P independent variables that we removed from the model, okay? So this part of explanation power is the explanatory power of the P independent variables that we removed from the full model, okay? So what we want to see is that whether this part is significant to the errors of the full model, okay? So if it is significant large, then we believe those P independent variables has a very significant, contribution in the explanatory of the whole total variation. If it is small, then we think, okay, it's okay to remove all those independent variables, okay? So that's how we constructed the F. So for the F, is actually the SSR of the full model, which is this part, which is SSR of the full model, and this part will be the SSR of the reduced model, right? So SSR full model, SSR reduced model, and then divided by its degree freedom. So this is like also like a MSR difference, something like that. And this is also MSE of the full model. So MSR over MSE is again the F distribution, right? Okay, so if it's rejected, if null hypothesis is rejected, this means at least one of the beta I is not equal to 0. This means this kind of reduction is not valid because they are of very high explanatory power in the variation of y, okay? But if H0 is not rejected, so if not rejected, everything is 0. This means, okay, it's okay to remove all those independent variables from our model, okay? So that's all about the partial F test, okay? The partial F test. All right, let's see the questions. In the book lecture slides, they use K minus P. All right, sorry about that. So if you are use K, well, it's just different definitions, okay? So basically P, okay, if we define P as the total number of the independent variable that is remaining, then this part should be P, right? Okay, sorry about that. If so, can you rewrite the null hypothesis? I miss it and it's a bit unclear. Okay, well, if we define this part as P, then the null hypothesis should be beta 1 equal beta 2 equal to the beta P equals 0, right? And then at least one of the beta I from 1 to P is not 0, okay? And here we should be K minus P. Well, it's just the difference, right? It's just how many, this means how many independent variables that we removed from the model, right? So it doesn't matter what kind of letters we're gonna use in this test, okay? It's all about what does that mean, okay? So in your cheat sheet, if you know what does that mean, it doesn't really matter, okay? All right, so now finally, let's go back and see our questions. Okay, I still have a step 5, which is the assumption, right? So the assumption is something that we'll discuss later on. But let's firstly look at a question, okay? And hopefully you can understand more about those knowledge by practicing on this question. All right. So this question is about a simple linear regression. It says a young aggressive investor plans to buy some BHP shares for short-term investment. So it's just a background introduction. He will invest in the stock if the daily percentage return of BHP share price is higher than the daily percentage return of the all ordinary index. So this sentence is later on will be very important, but so far you can't see any importance of this sentence, right? But you know, he will invest in BHP stock if the stock return is higher than the market, right? Market is the all ordinary index. So he collects the daily percentage returns of BHP and AORD from June the 1st to 31st of May and uses a simple linear regression to help him to make a decision. He obtains the following results. Okay, so this is the following results. Hopefully you can read them. And hopefully it's clear enough for you to read. Let's see the byte rate. The rate here is 1.8 megabytes per second. So it should be very clear, like HD videos, right? Okay. All right, first First question. It is asking to write down what? Write down simple linear regression model that this investor uses. Okay, so we are asked on the model. So when we're asked on the model, what should we write? With epsilon or not with epsilon? With epsilon. Do we have hat? No hats, right? Okay, let's try and write down the simple linear regression model that the investor uses. What is the dependent variable? Which is the percent return of AORD, right? So we just write down percentage return of AORD equal beta 0 plus beta 1 times percentage return of BHP plus an epsilon, okay? So this is just the simple linear regression model that the investor uses, okay? All right. Secondly, test at the 5% level of significance whether the regression coefficient beta 1 is greater than 1. Note that the critical value is something 1.645. So as we can see, this question is actually asking us to do what? Seemingly to do a independent individual significance test. But you know, what we did in our individual significance test is that beta 1 equals 0 against beta 1, for example, not equal to 0. But now we want to test if it is greater than 1. So some student might start confusing, oh my god, what is that? All right, so okay, oh yeah, sorry about that. Yeah, I think so. Thank you for Lisa Zhang. The dependent variable should be BHP. Yeah, we want to see if BHP is greater than AORD. Sorry about that. This is like the calculation of beta, right? Sorry. Yeah, we need to see this is return of BHP against here. Return of BHP against the return of AORD. Sorry, I didn't have my dinner, so I sort of lost my mind. Okay, but anyway, we want to test actually here is whether beta 1 is equal to 1 or beta 1 is greater than 1, right? So what should we do in order to perform this test? So this involves your understanding of the test statistics T, right? So in order to get full mark, you know, we need to under like H0, the test statistic is what? T. And this T is actually beta 1 hat minus beta 1. Our hypothesized beta 1, which is 1, and then divided by its standard error of beta 1 hat, okay? So, what's happening? What's happening here? It's actually consultation, all right? Well, just ignore it. That happens. Okay. All right. So this is the test statistic, and it follows what distribution? A T distribution with a degree of freedom n minus k minus 1. Okay. So this is how we construct our test statistic. Okay, and hopefully you all remember it or all put it in your cheat sheet. Okay. And next, we need to state our decision rules, right? So the decision rule is that H0 is rejected at 5% like level of significance if what? If what happens? If the observed value of the T is greater than t critical, right? So the t critical should be t half of alpha or just alpha. Alpha, because this is a one-tailed test instead of a two-tailed test, okay? So this is a one-tailed test, alpha, and the degree freedom is n minus k minus 1, okay? So we will later on figure out what is n, what is k, and whatsoever, okay? All right, now, the t observed is actually beta 1 hat. So what is the calculation value of beta 1 hat? It's actually over here, which is 1.2992, I guess. 1.2992 minus 1. 1 is here, right? Minus 1. And then divided by the standard error of beta 1 hat. So the standard error is actually here, which is 0.0321, okay? 0.0321 divided by 0.0321. So can anyone calculate this result for me? Okay, so just calculate this result for me and I will figure out the n value and the k value here. So alpha in this question is just 5%, okay? This is 5%. And n minus k minus 1 is actually, let's see, n here is 252, right? And minus k is actually 250, right? And actually, it already gave us t 250, 0.05 is something, right? Okay. It's 9.32. Thank you. 9.321 will be definitely greater than 1.645, right? 1.645, and therefore it's what? The H0 is rejected, and we have enough evidence to say that what? The coefficient beta 1 is greater than 1, right? The coefficient. So you know it's rejected, and then you just draw the conclusion, okay? We have enough evidence to say that the coefficient beta 1 is greater than 1. Okay, some student is asking, wait, but how come the output shows AORD as beta 1? Well, this means the coefficient on AORD is beta 1, okay? So it's just like this, beta 1 and percentage return of AORD, okay? All right, therefore we know beta 1 is greater than 1, right? Now, let's look at the next question. Do you think that this investor will buy some BHP shares? So when will this investor buy BHP shares? This is when what? He will invest in the stock if the daily percentage return is higher than the daily percentage return of the ordinary index, which means if beta 1 is greater than 1, then he will definitely invest in this stock, okay? So from what we calculate in the second part, we have proved that the beta 1 is greater than 1. Therefore, we believe that this investor will definitely buy some BHP shares. Okay, everyone happy with that? So yes, because from the results, the test result from question 2, we know beta 1 is greater than 1, which means the return of BHP is sort of greater than the return of AORD, and then we believe, this investor will buy some BHP shares. Okay. All right, that's all about this simple linear regression question. So do you have any questions on this part, like simple linear regression? If not, we're gonna move on to the multiple linear regression. Okay. All good? Yeah, great. Now, let's go to see this multiple linear regression question. Okay, this question is very bad. Why? Let's read it together, okay? So first of all, A sales manager of a BMW car dealer wants to study the relationship between what? Between the recommended retail price of a certain car Y and the specifications of the car. So what is the dependent variable in this question? The RRP, right? The recommended retail price. What about we have a rest and I get some water? Is that okay? Because I'm too tired. Okay, I'll go back very quickly. Okay, I'll get some water. And you can read the question here. Okay, and identify what are the independent variables. Okay, guys, I'm back. Okay, so let's read this question together. So the independent variables he considers are firstly engine size in liters, and secondly power, which is kW. Thirdly, transmission type, 0 for manual and 1 for auto. Okay, and fourthly, series of the vehicle. So this is very interesting because the series we define 1 as series 1, 2 as series 3, and 3 as series 5, and 4 for 6, 5 for 7. So when you make a prediction later on, and it tells you it's a series 5 car, then you need to input 3 over here instead of 5. Okay, because 5 is for series 7. All right, so this is a little bit annoying, but this is the thing that we need to pay attention to, okay, when you read the question. Now, he collects relevant data from a random sample of 21 BMW cars and develops a multiple linear regression model to study the relationship. He obtains the following results. Okay, so the results are as follows. Okay, firstly, write down what? This multiple linear regression model. Okay, so multiple linear regression model, very easy. Again, it should be of y and several x's, right? So it's simply y equal beta 0, because in this question, they already define the y and x, so you don't need to write RRP equal engine size, power, transmission type, series of vehicle, or whatsoever. Okay, so you can directly use x1 beta 2 x2 plus beta 3 x3 plus beta 4 x4 plus epsilon. So this is exactly a 1 mark secured. Okay, because this one was 1 mark. Write down this multiple linear regression model, 1 mark secured, right? So this is question 1. Now, question 2. Question 2 is asking to write down the estimated linear regression equations for manual transmission and automatic transmission BMW cars. So this is all about your reading of the questions, right? So the linear regression equations for manual transmission and automatic transmission, it must be involved in a dummy variable or indicator variable. Let's see the transmission type. If the transmission type X3 equals 0, then it stands for the manual, right? And if it is 1, it stands for the auto transmission type. Okay, so what we can do here is to just write down the estimated linear regression equations, which we need to use the data over here, right? The coefficients on those independent variables, right? Now, let's suppose a transmission type equals 0, which is a manual first, okay? So for manual transmission, it's gonna be what? For manual ones, it's y hat equal what? Beta 0 is minus 91.3449 plus x1 is 31.6130 x1 plus 0.2852 x2. x3 equals 0, so we don't have this guy, right? And then plus 29.8859 x4, okay? So this is the prediction equation for the manual typed question, right? Well, Han Chen says, should we use I3 instead of X3? Well, the question defines X3, so you can use X3, okay? So if the question defines I3, then you use I3, okay? All right, so that's about the manual case. Now, automatic case is when x3 equal to 1, right? So for the auto case, again, it's y hat equal minus, so this should be 91.3449 plus this minus 11.8153, because the intercept term will be adjusted by this indicator variable, right? So we need to add this intercept and this guy together, and we get minus, can you help me calculate this result? Or I can calculate it by myself as well. It's what? It's equal to 191.3449 plus 11.8153. So the result is 103 so it's minus 103.1602, I guess. So have we all got the same result? Yes? Oh, nobody is calculating. I'm so sad. Okay, so this is the result. Minus 103.1602. And then we plus, again, same, 31.6130 x1 plus 0.2852 x2, and then plus 29.8859 x4, same thing. But the only difference is the intercept term, right? Good. Okay, all right, so far we finished the estimated linear regression equations for manual transmission and automatic transmission. So all of those are very easy for you, right? Why we have a drop in the audiences? You think it's too easy? I guess so. All right, so the third question involves the interpretation of the coefficients on the indicator variables. Let's see. It is asking how much more do you expect to pay for an automatic BMW than a manual BMW of same specifications? And is this what you expect? So, how much more do you expect to pay for automatic than a manual? So for automatic, x3 equal to 1, right? So for automatic, it's 11.8153, actually less than the manual BMW, right? So we probably need to answer that the how much more, actually it's 11.8153 less we expect to pay for an automatic BMW than a manual BMW of the same specifications. Okay, so this sentence is also the interpretation of the coefficients on the indicator variables. okay? All right, so one thing we need to pay attention is that this value has its own unit. It's in thousands of dollars, okay? So what we actually need to do is to put the 1,815.30 dollars less we expect to pay for it, okay? So we need to pay attention on the units of the whole of the whole scenario, okay? So the units of RRP, this retail price is in thousands of dollars, so you need to pay attention on that. So is this what you expect? So what does that mean? So let's think about our common sense. Do you think automatic car and the manual car, which one should be more expensive? Manual or automatic? Exactly. Automatic car is always more expensive than a manual car. Therefore, what we need to do, what we need to answer is that this is not what we expect, right? Because in real life, automatic cars are much more expensive than a manual car. So that's not what we expect. So is this what you expect? No, this is not what we expect. All right, so that's all about question 3, okay? Now, question 4. Question 4 is asking, show that the transmission type is not a significant factor in determining the RRP of a BMW car. So what is this part testing? It's actually testing on what? Overall significance or individual significance? Individual significance. Good. So you must state the null hypothesis or training hypothesis or test and use alpha equals 0.05. Note that t equal to 2.12. Okay. So here we need to state null hypothesis, which is what? Which beta? We're testing on transmission type. So transmission type is X3. So this model is beta 3, right? So we need to test beta 3 significant factor. So whether it is 0 or not. Is that right? So this is quite easy, I guess. So that's all about the null hypothesis and the alternative hypothesis. And under null hypothesis, we know that the test statistic is given by what? Do you remember? It should be the beta 3 hat minus 0, which is the hypothesized parameter, and divided by the standard error of the beta 3 hat. Is that right? And this guy follows a t distribution with a degree of freedom of n minus k minus 1. And as we discussed just now, n minus k minus 1 equal to 250, right? Because oh, no, this is not the same question, sorry. Observation n is 21, no, n is 21, and k is 4, right? So k is 4 minus 1, so it's 16. So this is PT 16. All right, so when do we reject null hypothesis? It's when the observed value of t, I mean the absolute value of it, greater than the t 16 0.025, right? And this value is also provided in the question or in your table, statistical table. So you need to know how to look it up on tables, okay? So this is the decision rule. So finally, let's calculate the observed value. So the observed value is beta 3 hat. So what is beta 3 hat? Minus 11.8153. So minus 11.8153 minus 0 divided by standard error. So what is the standard error? It's 12.5560. So you can see the t-stats, p-values, the confidence intervals are all missing. So you need to perform the test by yourselves, right? Okay, so divided by 12.5560, 5560. Can anyone calculate this result for me? So what is the observed t? I've got 0.9410 in my Excel. Is it? Beautiful. Well, we are taking the absolute value, so it's all positive. And obviously, this guy is definitely less than what? Less than the critical value, which is 2.2. Therefore, H0 is rejected or not? Is not rejected, and we have enough confidence to say that what? Say that the transmission type is not a significant factor in determining the RP of BMW car. So you just you just write down whatever you are asked in the question, okay? And that's enough. All right, so that's all about question 4. Are you happy with that? Okay, so this is not all of the question of this question, because as you can see, we still have a lot of knowledge that haven't been tested yet. So let's move on to the next page. Wow, come on. Now, the sales manager now believes that there is something wrong with his analysis. So what do you think is probably something wrong? Let's see. If we look at the p-value of each independent variable, we can actually see some p-values are too large, which means some independent variables are not significant, right? Okay, so Clary Huang is asking, when do we use overall and when do we use individual? So if the question is asking you, is the model overall significant, then you just read the ANOVA table. And if the question is asking if any of the independent variable is significant, then we use this t-test, okay? So that's pretty straightforward, don't worry. Okay. They are actually, those two tests are different for different purposes. So the purpose it will be very clear in the question, okay? All right, the sales manager believes that there is something wrong with analysis, and he consults a business analyst. The business analyst suggests him to use a stepwise regression to choose the best subset of independent variables. So actually, this involves some removal of unimportant or insignificant independent variables. Just like here, we can see x2 and x3 as what we tested are not significant, right? Okay. So the sales manager takes this advice and finds the following new results. So we can see a lot of blanks here. This involves a lot of calculation for us. Okay, so interpret 5. Interpret both p-value in the overall significant test of the regression model and the p-values in the individual significant test of the regression coefficient. Use alpha equals 0.05. So for overall significance test, it is actually asking us on this value, right? So this is the p-value for the overall significance test. And for the individual significance test, they are just here, right? So what do we need to do in order to interpret is, I guess, we need to firstly state what are the null hypothesis and alternative hypothesis of those tests, right? So for the overall significance test, we know the null hypothesis should be beta 1 equal beta 4. We know the new model only consists of 2 independent variables, right? So beta 1 equal beta 4 equals 0, and the alternative is at least one of the beta 1 and the beta 4 is non-zero. So this is what we're gonna do for the null hypothesis and alternative hypothesis. And the p-value, so we only require to interpret the p-value, right? So the p-value here is equal to what? Let's see, 0.0000, isn't it? Okay, so it's very small, 0.000, which is definitely less than alpha, which is 0.05. Therefore, H0 is rejected, and the model is what? It's overall significant, right? Or is overall significant to the explanation of the variations in y, okay? So that is what is covered here, okay? Now, we still need to interpret the p-values in the individual significance test. So this is for overall significance test. And for individual significance test, we'd better look at all those p-values, right? So we just state one null hypothesis, which is beta I equals 0. Alternative is beta I not equal to 0. I can be equal to 1 or 4, right? So you can say since all the p-value, actually 0 can also be included here, because we can also test on the intercept, which is the beta 0, right? So since the p-value for any of the any of the coefficients is just close to 0, so all the independent variables as well as all the coefficients are significant, right? So everything is significant. So I'm just lazy to write it in only 2 lines, because it only worth 2 marks, right? You don't need to write too much. So you can say p-value for all the the variables of the coefficients is close to 0, and we can conclude that all coefficients are significant, okay? So this is not hard, right? Now, let's look at the next question. It's also asking us to interpret the regression coefficient of x1. Okay, so Kelly Wang, let's answer Kelly Wang's question first. Kelly Wang is asking, in simple linear regression model, which test should we use to test beta 1, overall test or individual test? I can answer you that both of the tests will give you the exactly same results. Why is that? Let's see. We can see this simple linear regression here. Actually, this significance f will be exactly the same as this p-value, okay? So it's just 0.00. Or this t statistic, if you take a square of it, it's just this f statistic, okay? So you can try a square root of this f and you will definitely get this t, okay? So this is very interesting. Those two tests will give you the same results if it is a simple linear regression, okay? So yeah, that's the point I want to make. So this p-value will equal to the p-value on beta 1. And this f will be the square of t, okay? All right. Any other questions? If not, let's move on. So all those questions are fairly easy now, other than the last one. Let's see. Interpret the regression coefficient of x1. So how do we interpret it? So very easy. We talk it a lot in our class, right? So it should be keeping all other variables constant. This is very important, right? Keeping all other variables constant. Then a 1 unit, well, what is the unit here? x1 means what? x1 is the engine size, right? So a 1 liter increase. So a 1 liter increase in engine size will result in a how many increase? 49.31. But keep in mind, this unit is thousands of dollars, right? Will result in a $49,310 increase in the RRP, which is the recommended retail price. And another important thing is on average, right? On average, okay? So two things, keeping all other variable constant, probably worth 0.5 mark. On average, worth another 0.5 mark, okay? So that is how it can be tested when you interpret the coefficients, okay? Now, question number 7, okay? Question number 7 is asking, find the estimate of the error standard deviation. Oh my God, what is it? Error standard deviation, it's simply square root of MSE, right? Okay, good. So, for question 7, actually the error standard deviation is simply the sigma error hat, and it's equal to the square root of MSE, and we know the MSE in the table is 386.97, so it's the square root of 386.97. So can you please calculate this result for me? Equal square root of 386.97. It's 19.6716. 19.6716. Is that right? Okay. So we know that this value is also corresponding the standard error in the summary output, right? So we can fill in 19.6716 in here. Okay? So that is pretty easy. So if you know it, you know it. But if you don't, you just have no idea what this question is asking, right? Okay. Now, let's look at question 8. For question 8, it's asking us to show that R squared equal to this bad boy and hence find correlation of y and y hat. Oh my God, what is this? Do you remember? It's multiple R, right? Okay, so that's how can it be tested, okay? All right. So, let's look at question 8 together. Show that R squared. So R squared, we know it's calculated by SSR over SST, is that right? But the problem is now, all of those SSROTs are blank. So we need to fill in those blanks manually in order to get all those values, right? Okay, so first of all, the degree freedom are the easiest ones. For regression, degree freedom of SSR, oh sorry, it's 10 p.m. so I need to turn on the light manually and turn on the air conditions. Okay, I'm back. Yeah, I'm currently in ABS, so 10 p.m. ABS, all lights will be power off, right? Okay, now let's look at regression and residual. Regression degree freedom should be 2 here, so residual is 18 because we have 2 independent variables here, which is x1, x4, and then residual is just 20 minus 2. All right, now the only thing that we need to work out is the sum of squares, SSE and SST, right? So how can we calculate this SSE? Well, we have MSE and we have its degree freedom. So how do we calculate this SSE? It's simply 18 times 386.97, right? Okay, so quickly calculate SSE together. So equal to 18 times 386.97, which is 6965.46. 6965.46. Beautiful. Now we can work out the total. Well, total is this bad boy plus 193282, 193282.05, and the result is 200247.51. Okay, so we got all of those, and we have SSR over here and SST over here, right? So what we can do is just plug in the numbers. 193,282.05 divided by SST. So actually, without any calculation, you know, sorry, you know that R squared must equal what? What you need to prove, right? 0.9652. You can just calculate it and check if you got the same result. So this is how you calculate R squared. Now, R squared 0.9652. Okay, done. Now, another part of this question is to hence find correlation between y and y hat. We know correlation between y and y hat is what? Multiple R. So the correlation between y and y hat is simply multiple R, which is the square root of R squared, and it's finally square root of 0.9652, and I will calculate it for you. Square root of 0.9652, and the result is 0.9824. Okay. Oh, what's wrong? Okay, good. So this is 0.9842. Everyone happy with that? Beautiful. Okay, so that's all about question 8. Okay, R squared equal 9, and find correlation between y and y hat. All right. Now, question 9. Look, it's about the prediction, right? Okay, so for the prediction stuff, let's see. BMW is going to launch a new 3 Series Saturn. Okay, 3 Series. We need to know 3 Series is X4 equal what? X4 3 Series, X4 equal 2, okay? So X4 here equal 2 instead of 3, all right? Okay, so 3 Series, so X4 equal to 2. Automatic transmission, so does it really matter? No, because our final model does not have transmission type. It's not a significant variable. And the engine size is 2.2 liters, which means X1 equal to 2.2. And the power is 135 kW, and we know the power has also been removed from our full model, right? X2 and X3 are removed. We only left X1 and X4, okay? So X4 is 2, X1 is 2.2. So our prediction function should be y hat equal to minus 102. Let's copy it down. 102.20 plus 49.31. This is X1, so times 2.2, and then plus 31.27 times the series, which is 2. Okay, so we can quickly calculate this result. Can anyone help me? I don't want to type like everything into Excel, so help me calculate this result. Good, 68.822. Thank you, 68.822. 2. All right, but finally, you need to convert it into dollars, right? So it's $1,000, $68,822 for this specific sedan car. Okay, thank you. You all get the right answer. Thank you. All right, so that's all about question 9. Now, the final boss for today's question is question 10. Let's see, what is it asking us? Perform a formal statistical test to show that the full model in 1 can be reduced to the model suggested by the stepwise regression technique. So which means in 1, we got a model, we got a full model in 1, which is including all independent variables, right? However, it is asking us whether we can, whether this full model can reduce to this restricted model, which only contains 2 independent variables. You must state the null and alternative hypothesis, calculate the value of the test statistic, and draw your conclusion based on alpha equals 0.05. And F value has already been given. All right, so this question is about the restricted F test or reduced F test or partial F test, right? Okay, in terms of this F test, we want to know if the independent variables that we remove from the full model has significant explanatory value to the model, right? So firstly, what are the 2 independent variables that we've removed from the full model? So we have x1, x4, so we removed x2 and x3, right? Therefore, the null hypothesis should be the beta that we removed, x2, x3 equals 0, right? And the alternative should be at least 1 of the beta 2 and the beta 3 is not equal 0, okay? So this is the null hypothesis and alternative hypothesis of the restricted or partial F test, okay? This is for partial F test. And the test statistic, as we've discussed just now, is actually what? SSR of the full model minus SSR of the reduced model, then divided by the number of variables that we removed, which is 2, right? So we removed 2 independent variables, so we put 2 here. And then divided by the SSE of the full model divided by n minus k minus 1. So n minus k minus 1, as we can see, it's 16 in this question, right? This is the output result of the full model, and the n minus k minus 1 is 16. So this is 16. And this test statistic follows F distribution with a degree freedom 2 and 16. Therefore, the observed F can be calculated by, we find SSR full model and SSR reduced model. So where can we find all those values? Let's look at the SSR of the full model. It should be in this table, right? So what is the SSR of full model? It's 194530.75, right? So it's 194530.75. And what about the reduced model? Reduced model is 193282.05. So let's write it down. 193282.05. And then divided by 2. And then divided by SSE full model. So what is the full model SSE? Shall we look at this table or that table? Yeah, that table, because this is the full model. And let's find the full model SSE, which is here, 5716.74. Okay, divided by 5716.74. And then divided by the residual degree freedom, which is 16. So help me calculate this result. Thank you. Thank you very much. And I'll drink some water during this. Wow, you're so fast. Rennie Chen has calculated this value as 1.7474. And we know this value is no larger than 3.63. No larger than 3.63. Therefore, we reject or not reject? We do not reject null hypothesis, and we conclude that the full model can be reduced to the that technique. Okay, so you just state here. Okay, we can conclude that, or we do not have enough evidence to say that the full model cannot be reduced to the model suggested by the stepwise regression technique. Okay, or you can say we have enough evidence to say, oh, we cannot say that. Okay, whatever. You just draw a conclusion. Is that okay? All right. So we do not reject H0, and therefore, which means beta 2, beta 3 all equal 0. This means the model can be reduced, right? In short, model can be reduced by the something like stepwise regression technique. You can just copy the question, okay? The full model can be reduced to the model suggested by the blah, blah, blah technique, okay? Okay. That's all about the linear regression question. So do you have any other questions? Yes, any other questions? Could you please explain more structures of QQ plots, like the bridge is likely a symbol of y minus x2. What do you mean by that, Han Chen? Well, more structures of QQ plots. Sorry, I didn't really get your question. Well, let's answer Felisa Zhen's question first. Will we be tested on transformations of y and x? Well, as I said, everything is possible. But how can that be tested? They probably just give you a scatter plot. Very easy, scatter plot. For example, quadratic. And then ask you what kind of transformation can you do? Then you just say, okay, quadratic transformation, right? You just put x squared instead of a simple x over there, okay? Something like that. So you just be able to read the scatter plots, and then you'll be fine. All right. Have you all finished your revision? Or you want to have another consultation tomorrow? So now let's have a quick roll. Like, do you want to have another consultation tomorrow? Because today it's already 2 hours and I'm very tired now. So Han Chen, yeah, Han Chen, it's asking the same question as Felisa asking. So if we look at the residual plot, and if it is a quadratic term, then it shows the relationship of a quadratic relation, right? Hell to the yes. Okay, I know, because tomorrow it's like a last minute consultation, so everyone must have a lot of questions. So I will also prepare the calculation of beta tonight, and hopefully tomorrow I can explain that to you for Felisa Zhen. Is that okay? All right, thanks for watching for today. And as I mentioned, I will upload those exam papers on this YouTube link. I mean, on YouTube. Okay, logistic regression tomorrow. Okay, we'll do logistic regression tomorrow. I'm so tired. I need to have my dinner. Thank you very much. Tomorrow, same time. Yes, 8 p.m. I will post another announcement on Canvas. Is that okay? All right. So that's all for today's upload. Yeah, I can. Yeah, I can upload this. I'll do it right now. Okay, I will upload this on a okay, I'll do it later on. Okay, so you will definitely have it. You cannot download this video, you can only watch it online. Okay, all right, that's all for today. Thank you very much, and hopefully can see you tomorrow. Okay, bye bye. Okay, I can show you where am I. Okay, I'm in ABS. Nobody is here. Everything is dark. Only me and my devices. So that's why this device is not stable. Look, it's very unstable, and I need to use my computer to hold it. All right, that's all for today's live streaming. Thank you very much for watching. I'll see you tomorrow. Bye.